Dear students, in this session we will discuss upon projections. As we know, projection, by use of projection we transform points in a coordinate system of dimension n into points in a coordinate system of dimension less than n. Transformation of three-dimensional objects into a two-dimensional place using projection. The projection of a three-dimensional object is defined by a straight projection rays called projectors, emanating from a center of projection, that is known as COP, which passes through each point of the object and intersects a projection plane to form the projection. In general, there are two types of projections: parallel and perspective. In parallel projection, coordinate positions are transformed to the view plane along parallel lines, whereas in perspective projection, any set of parallel lines that are transformed to the view plane along lines that converge to a point called projection reference point, or in other words center of projection. On a screen you are seeing two figures A and B. In A, line AB and its perspective projection A dash B dash, whereas line AB and its parallel projection A dash B dash in figure B. Projectors converts, or we may say projects A as A dash and B as B dash. Perspective projection. The perspective projections of any set of parallel lines that are not parallel to the projection plane converge to a vanishing point. If the set of lines is parallel to one of the three principal axes, the vanishing point is called an axis vanishing point. There are at most three such points corresponding to number of principal axes cut by the projection plane. Let us take an example. If the projection plane cuts only the z axis, which is therefore normal upon it, and only the z axis has a principal vanishing point, because the lines parallel to either the y or x axis are also parallel to the projection plane and have no vanishing points. Let us see this figure. One point perspective projection of a cube or to a plane cutting the z axis, showing vanishing point of lines perpendicular to projection plane. So, by figure you will get understood. So, in perspective projection, one point perspective projections of a cube or to a plane cutting the z axis, showing vanishing points of lines perpendicular to projection plane. Perspective projections are categorized by their number of principal vanishing points and therefore by number of axes the projection plane cuts. As in previous figure, you have seen that two different one point perspective projection of a cube, and now it is clear that there are one point projection because line parallel to the x and y axis do not converge, only lines parallel to the z axis do so, as in figure B. Thus, we see that perspective projection is classified according to number of principal vanishing points in a projection. 1 point, 2 point and 3 point projections. 2 point perspective projections is commonly used in architectural engineering, industrial design and in advertising drawings. 3 point perspective projections are used less frequently since they add little realism beyond that afforded by the 2 point perspectives. So, now we come to the parallel projection. Parallel projections are categorized into two types, depending on the relation between the direction of projection and the normal to be projection plane. One is orthographic parallel projection and another one is oblique parallel projection. Let us see orthographic parallel projection. The most common type of orthographic projections are the front elevation, top elevation, also called plane elevation, and side elevation projections. These orthographic projections are called multi-view 2, since these provide facility to view an object by various sides like front, right side, left side, rear I mean ki back, top, bottom, and all these the projection plane is perpendicular to a principal axis, which is therefore the direction of projection. You are visualizing the screen which shows that side planes can be projected beside them, the front plane are projected forward, the top plane is moved to upward. All these are clearly shown in the figure on screen. So, another orthographic projection is axometric orthographic projections, which use projection planes that are not normal to a principal axis and therefore show several faces of an object at once. These resemble the perspective projection in this way, but differ in that the foreshortening is uniform rather than being related to a distance from the center of projection. Parallelism of lines are preserved, but angles are not, while distances can be measured along each principal axis. Axonometric projection can be classified as isometric, diametric and trimetric. Isometric. In isometric, the direction of projection makes equal angles with all the three principal axes, whereas in diametric, the direction of projection makes equal angle with exactly two of the three principal axes, whereas in trimetric, the direction of projection makes unequal angles with all three principal axes. The isometric projection is a commonly used axonometric projection. The projection plane normal, I mean ki perpendicular, that is the direction of projection which makes equal angles with each principal axis. If the projection plane normal is dx, dy, dz, then we require that modulus dx is equal to modulus dy is equal to modulus mod dz. There are just 8 directions, one in each octant, that satisfy this condition. So, in the figure on screen, it is clearly shown that the construction of an isometric projection along one such direction represents 1, -1 and -1. All these are shown in the figure. The isometric projection has the useful property that all three principal axes are equally foreshortened, allowing measurements along the axis to be made to the same scale. Hence, the name iso, which means equal, and metric, which means measure. In addition, the principal axes project so as to make equal angles one with another as in instant figure. The another one that is oblique projection. It is one of the type of parallel projection. It differs from orthographic projections. It combines properties of front, top and side orthographic projections with those of the axonometric projection. The projection plane is normal to a principal axis. So, the projection of the face of the object parallel to this plane allows measurement of angles and distances. Other faces of the objects project also, allowing distances along principal axis, but not angles to be measured. In the figure, it is clearly shown the construction of an oblique projection in which projection plane is normal and the direction of projection are not same. You were observing that it has been slightly slant. Oblique projections are further classified as cavalier and cabinet. For the cavalier projection, the direction of projection makes a 45-degree angle with the projection plane. As a result, the projection of a line perpendicular to the projection plane has the same length as the line itself. That is, there is no foreshortening. So, in the instant figure on the screen shows several cavalier projections, one upon 45 degree, another upon 30 degree. Shows of the unit cube onto the xy plane. The receding lines are the projection of cube edges that are perpendicular to the xy plane and they form an angle. As in figure, one is on 45 degree and another one is on 30 degree. Cabinet projection. Cabinet projections have a direction of projections that makes an angle of arctan 2, which is equal to 63.4 degree with the projection plane. So, lines perpendicular to the projection plane project at 1/2 their actual length. Cabinet projections are a bit more realistic than cavalier ones are, since the foreshortening by 1/2 is more than keeping with our other visual experiences, as in the figure B. So, these are all about projections. In these slides, I have drawn a hierarchy chart, how the geometric projections are classified further. In first step, that becomes to parallel and perspective. In part of parallel, that is further classified as orthographic and oblique, and orthographic further top, front, side, axometric, which is further classified as isometric and other, and in oblique part cabinet, cavalier, other, and the another one that is perspective, which have 1 point, 2 point and 3 point. So, the entire projections, entire type of projections which have been classified here have discussed with you, and I hope you all were understood what is projection and in how many ways we can project an object. So, that is all. I am trying to show you one program of perspective projection. Okay. So, students, this is a program which is the codes are written on using the perspective projection algorithms and concept. So, it will show that in perspective projection how an object appears. So, let us execute the program. All the values, I mean values is nothing, that is coordinates, I have initialized, and we will show that it will show the both figures, the original and the projected one. So, let us compile and on the screen you are seeing a figure like cube, but that is not actually a cube. You are seeing that the front face, the front side is with other line, whereas the back side is with other lines, and both are separate and they are showing connectivity with 4 dot lines. You are seeing that the original one is in like a sky color, whereas the front side is of red color, and within a time span it makes change as you have just seen. So, this is the way how the perspective projection works. Now, you may see that the object has been altered, you are appearing. Okay. So, this is all about projections. Thank you.